we're going to be talking about graph analysis and curve sketching. Now, we're not really learning new skills today in terms of, new stuff that we haven't really talked about. We're just going to kind of be talking about what we already know, but in new ways, really specifically looking at it more graphically and less algebraically with our equations. So here we have a graph of f prime, and we want to know, what does the first derivative graph tell us about our original function f, maybe our second derivative, basically what's all the information we can gather. And hopefully you remember to do the calculus house from the second derivative notes. But just as a reminder, our calculus house is f, f prime, f double prime, and then for each of them, positive, negative, increasing, decreasing, concave up, concave down, and then it just scoots over by one set. Okay, so that is our calculus house, just something kind of shorthand to help us remember our information, namely that when our first derivative is positive, negative, our original function increases or decreases. When our second derivative is positive, negative, our original function is concave up or concave down. So that builds off the same information that we know. We just kind of filled in some extra information based on what we've seen or what we've observed. Okay, so now let's look at f prime. So this is the derivative graph. This is not f. Note specifically that it is f prime. It also tells us in the problem that it is f prime. It's always very important to know what function you're looking at. Okay, so since I'm looking at f prime, I'm thinking everything in terms of, what does this information tell me about f and f double prime? Okay, so notice if I have f prime, I can get lots of information about f and lots of information about f double prime. Okay, so what are the critical points of f of x? Remember, critical points occur on f prime when f prime of x is equal to 0 or undefined. Okay, now looking at our curve, we don't have any points that are equal to 0, but we do have we don't have any points where it's undefined, but we do have spots where my f prime graph is equal to 0. So where are the critical points? Everywhere where f prime crosses the x-axis. So here at A, C, D, F, and H. So what are our critical points? A, C, D, F, and H. So critical points appear when f prime is equal to 0. Where is f of x increasing? Okay, so remember, f of x is increasing when f prime of x is positive. So f prime of x is positive everywhere where it's above the curve. So it's increasing from here to here, from here to here, and from here to here. And technically it increases all the way from f to the end, okay? But we do have to stop at h, because what did we already say h is equal to? H is equal to 0. So it's not increasing or decreasing at h. So we do have to still split it up. So where is f of x increasing? We would say from negative infinity to a, in union with c to d, in union with f to h, in union with h to infinity. Okay, so where is f of x decreasing? It's just going to be that opposite. F of x is decreasing when f prime of x is negative. So just that opposite sign, that opposite idea. So it is negative from A to C, which remember negative means below the x-axis, from D to F, and that's it. So A to C and D to F. In union with D to F. And notice really these should play off of each other because it's either positive, negative, or equal to 0. So I have all of my critical points, which are shown down here. And all my increasing intervals are different than my decreasing intervals. I shouldn't have any intervals that repeat. Okay, so that's a nice way to kind of check yourself on those. All right, number 4, identify the location of any relative maxima for f of x. Remember, relative maxima occur at critical points, and they specifically occur at critical points where f prime of x goes from positive to negative. So looking at our critical points, we have A, C, D, F, and H as candidates. So at A, we go from positive to negative, and at D, we go from positive to negative. So what are our relative maxima? A and D. Okay? Relative minima, same thing, but just opposite direction. So relative minima are when f prime of x, and that is impossible to read. Sorry, y'all. So relative minima are when f prime of x goes from negative to positive. So then up here on my graph, I go from negative values to positive values at C, and from negative values to positive values at F. So C and F. Notice there's one that I did not include. I did not include H, and that's because at H, I go from positive to positive. So I don't actually cross through the x-axis at H, which means it's not a relative maxima or relative minima. It's one of those cases where on F, I'm coming to, that flat curve and then continuing up. So it's going to create kind of that cubic shape. All right. Where is f of x concave up? Okay, now usually which graph do we use to tell us about concavity? Usually we'd use f double prime, but I don't have f double prime. So I need to go to my calculus house real quick and say f is concave up when f prime is increasing. So I need to look for my increasing intervals for when f is concave up. So f prime down here, when is f prime concave up? It is concave up when f prime of x is increasing in value. So now going back to my curve, we are increasing. So remember, increasing means my y values are going up. So I'm increasing in value from B all the way to, it looks like 0, okay? And then from E all the way to G, and then from H all the way to infinity. So B to 0, E to G, H to 0, or H to infinity, sorry. So B to 0 in union with E to G in union with H to infinity. Okay, so that is concave up. So a little bit weird. We haven't really talked about increasing telling us about concavity, but it's still true. It holds true from our calculus house. Okay, then keep on going. Where is f of x concave down? Well, concave down is just going to be the opposite. Going back to our calculus house, concave down is when f prime is decreasing. So where is f of x concave down? When f prime of x is decreasing. So then going back up to our curve, we should just be decreasing on the opposite intervals, unless we're staying constant, but constant is where we have maximum or minimum, that kind of stuff. So looking at here, we are decreasing from, it looks like negative infinity to B, 0 to E, and F to H. So it really should be those opposite intervals, right? For my concave up intervals. So we are decreasing from negative infinity to B, in union with 0 to E, in union with G to H. So opposite intervals. So just like with our increasing and decreasing, we're concave up, concave down. They should be opposite intervals of each other. So a nice little way to check them. Okay. Now this very last one, identify the location of any points of inflection for f of x. Okay. Points of inflection, remember, we usually get that information from our second derivative, points of inflection occur when our second derivative switches signs from positive to negative. So looking at our calculus house, if I'm going from positive, negative, negative to positive on f double prime, what's going to be happening on f prime? I'm going to be switching in between increasing and decreasing. So my points of inflection on f can come from a sign change on f double prime or an increasing, decreasing change on f prime. So identify any points. We use red. And so these occur when f prime of x goes from increasing to decreasing or from decreasing to increasing. And what's going to be happening when we're switching between increasing and decreasing or decreasing and increasing on the curve? Well, it's going to look like a relative max or a relative min. But on our f prime graph. So going up here, we switch between decreasing and increasing at B. We switch between increasing and decreasing at 0, decreasing to increasing at E, increasing to decreasing at G, and decreasing to increasing at H. So something you should also notice, 1, 2, 3, 4, 5. Okay, those also look like 2 relative maxes and 3 relative mins, but on f prime. Okay, so a little bit of a weird concept to think about, but kind of the same thing. It's all of these f prime, and f double prime, they all relate to each other. All their ideas kind of stack on top of each other, all right? And all the way down here at the bottom, points of inflection would be B, 0, E, G, and H. All right, y'all, and that is graph analysis. So now, y'all, we're going to talk about curve sketching really quickly. Okay, curve sketching is this idea of using our sign charts, using our information to actually sketch a kind of quick little picture of what the curve looks like. Okay, so we're going to look at number 1. So number 1, we have a continuous function. So all of these functions are going to be continuous that we're graphing today. That's very important. That means no asymptotes, no holes, no weird funny business. Okay, we know f prime at -1 is equal to 0. So I'm going to go ahead and add that into my sign chart over here on the right. So f prime at -1 would be 0. And f prime of 3 would also be 0. Okay, and then I'm telling you here on the sign chart, on f prime, we're going negative, positive, negative. So that would mean on f, I would be decreasing, increasing, and decreasing. And then on f double prime, we're going positive and then negative. So that means on f double prime, I would be concave up and then concave down. Okay, so before we can get to curve sketching, we have to talk a little bit about our shape. So we've talked about this a smidge before, but I'm going to kind of zoom in a bit. So if we have our concave up shape, okay, it's our nice parabola, right? But while it's concave up, it's not necessarily just increasing or just decreasing. It does both, yes? Our left side is concave up, but also decreasing in value. So that's concave up, decreasing. Our right side is still concave up, but it's concave up and increasing in value. So now when we combine these two ideas of both concavity and increasing or decreasing, we can create a specific shape of the graph, a specific shape of our curve. Okay, and that's what we're trying to do today. So same idea for our concave down. Okay, split it in half. On the left side, we are increasing, but concave down. So concave down, increasing. And then on the right side, we are decreasing, but concave down. So concave down, decreasing. Okay, all in all, this creates 4 different shapes for us for our curve. And we're going to use these shapes to actually sketch what our curve looks like. So this is concave up, decreasing. This is concave down, decreasing. And this is concave up, increasing, and concave down, increasing. Okay, so we have those 4 different shapes, these 4 pieces that we're going to use to actually sketch our graph. So over here, okay, I'm going to make one last sign chart, but this one is just going to be for F. Okay, and on my sign chart, I'm going to denote all of my critical numbers and my points of inflection. So boom, boom, and boom, -1, 2, and 3. Okay, and from -1, okay, notice I am decreasing all the way, and I'm also still concave up. So from -1, or from -infinity to -1, I'm going to be concave up, decreasing. So concave up, decreasing is that first shape. Okay, so that's the start of my graph. Then from -1 to 2, so at -1, I switch to increasing, but still concave up until I hit 2. So now I'm concave up, increasing, which is that other shape. Then after 2, I'm still increasing, but now I'm concave down, increasing. So concave down, increasing is this shape. And then at 3, I switch over to decreasing, but still concave down. So concave down, decreasing is that shape there on the end, like so. Okay, so now I kind of have the general shape of my graph. And then I just wanted to note what's happening at each of these points. Well, at -1, I switch from negative to positive, which means this is a relative min, because I'm switching from negative to positive on F prime. At 3, I'm switching from positive to negative at F prime, so this is a relative max. And then at 2, I'm switching between positive and negative, so this is a point of inflection because it's happening on the second derivative. So over here on your graph, y'all, doesn't really matter, but just kind of pick a line to be your x-axis and a line to be your y-axis. Shoop, 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 shoop. And then just go ahead and note these points. So I want 3. And let's see, 1, 2, 3. No, that's too far. So here's 3, 2, and there's -1. Okay, so I'm just going to go on here quickly, and it doesn't really matter the y values, but what I do want to make really clear is my relative mins, my relative maxes, my points of inflection, and then, of course, the shape. So at -1, I have a relative min. So I'm just going to pick a point under the x-axis because it's a relative minimum, so I want it to be really clear that it's a minimum. Note that I am not really worrying about the y value at all. I just picked a random point. Okay. Then at 3, I'm going to make a relative max. So I'm going to make it easy by picking a point up above. Okay. And then at 2, I want a point of inflection. So I'm just going to kind of create that shape so I know at 2 I should be switching between my 2 concavities. Okay. Then I'm just going to follow my information over here. So remember, my sign chart over here, this tells me my shape. So I'm going to follow my sign chart. So I'm starting with this concave up, decreasing. Then at -1, I switch from that to concave up, increasing. At 2, I should switch concavities. Then I go concave down, increasing. And then at 3, I start decreasing, but still concave down. All right, and that is kind of a very rough sketch of what our curve should look like. If you want to make it a little extra clear, you can add on here some labels. So Rmax, Rmin, point of inflection, just to make it a little more clear. If you're not super trusting in your artist skills like I'm not. All right, y'all, go ahead and pause me, and then you can unpause me here in a bit, and I'll have the rest of them filled in for you, okay?